Hi everyone, and welcome to our webinar on artificial intelligence. We're basically going to be unpacking AI and ideas for implementation for artificial intelligence. Karsten Schulz with me from the Digital Technologies Institute. So welcome, Karsten, and we're really looking forward to our webinar today and finding out a lot more about AI. And we've got a lot of people from all around Australia who's watching at the moment. We've got pretty good coverage, and we've even got people from New Zealand. So we better be good so we can get people to understand about AI. So really what we were trying to do today is to cover AI in terms of some very introductory information about AI, knowing there's got quite a few different people with different understandings, and we just want to walk through what AI is and machine learning, give you some practical scenarios, look at what some simple process to think about what AI does. We also want to demonstrate some AI applications and talk you through, how they're designed and what they're actually doing. I think you'll find it pretty informative today, and see what Karsten's got in store for us. We've also got some resources we've already got on the hub and some links to those resources. So in your console there, you've got a handout there. If you want to download that, that's a PDF of some of the resources and things. And in the chat, we're going to put in a link to a Padlet, because we'd like to know, first of all, what you know about AI, what experience you've had with some AI applications, and what you might be understanding. So with our Padlet, we're going to, if you can go into our chat, and you should be able to see a little link to that Padlet. It's a bit.ly link. We've just shortened it there so it's a lot easier. Now, Karsten's brought it up there. So the two questions are, what AI applications are you aware of? And the other one is, what do some of these applications do? So just to get a bit of an understanding there. So to be able to put in some of your information there, all you need to do is click on the cross and then insert some of your ideas. So we're pretty keen on finding out what people know about AI. I would think my first thing I'd expect some people to think about is that things like Netflix or some of those recommended type systems, Karsten, that people might be quite aware of. Karsten, do you reckon, is that what you're expecting? Some things about like Netflix, or what are some other types of things you might expect?
Yeah, I guess, yeah. Netflix, image recognition, super intelligent self-driving cars, these kind of things. Not sure if people are finding the link at the moment. At least on my side, it's not updating.
Yeah,
it should.
Yeah.
But we can certainly come back to the Padlet maybe at the end of the presentation, in case people want to type things in.
Yeah, just thought it'd be a good idea to see what applications people are aware of. As you mentioned, things like the self-driving car, and some of the other applications like Netflix, or some of those video type recommendation services that people might be aware of. But if we do come back to our Padlet, hopefully some people have got some good ideas to put into that. Let's move on to our next idea in terms of this framework, which was developed by CSCR, the people at University of Adelaide, our good colleagues over there, and they've been doing a lot of work on artificial intelligence, and they've allowed us to share this bit of a framework. So do you want to talk through that, Karsten?
Yes, and also very warm welcome from my side, and thank you for your patience with me, as the webinar was originally scheduled for last month, but I think we all agree that a webinar where the presenter has a voice is so much better than one without that. So again, thanks for your patience. So as Martin said, this is a wonderful slide from the CISA group from the University of Adelaide, and we wanted to take you through the process because it's a bit different with AI than what you maybe used with previously. So when we talk about AI and how it works, then we start with data. So the AI takes data, and these can be images, or sound, or text, and it processes this through some processing facility. It then thinks about the information. It tries to make sense of it. It performs a task, so it comes to some kind of decision, says, oh, that's what I see is a happy face. And then it uses feedback in order to self-correct. So if the AI believes it sees a happy face, but the data says, well, this is actually a sad face, then the AI will say, oh, I'm obviously making a mistake here. I need to change some of my internal behavior and do the whole task again. And this process can run dozens, hundreds, thousands, 10,000 times, depending on the data, before the AI has come to good outcomes that we would find acceptable. And what we find acceptable often depends on the application. We'll talk about that later. So that's just the high-level overview. If you just want to remember sense, reason, act, and adapt. And we will dive into that throughout the presentation. Okay, so let's ask the big question first. What is artificial intelligence? We can say that AI, as we lovingly like to abbreviate it, is the ability of machines to mimic human capabilities in a way that we would consider smart. And we're using the word smart here instead of intelligent for a certain reason, because some of the things that AI does are not yet quite intelligent, but they are smart. They're often domain specific. And you see examples here. Self-driving cars are all the rage at the moment. Face recognition, image recognition more general. Games, chess players, Go players. And these AIs, they are very domain specific. They can only play chess or Go, but they're so good at that they beat the best human player, and they actually beat the best other machine player. And these things are so fast, they teach themselves, I believe, in a matter of hours now, and become world class in that short amount of time. And then, of course, things that we're using every day, the likes of Siri, Alexa, and friends, these nice personal assistants that we have got in our smartphones that we can talk to, and they help us to make appointments and the like, and phone calls. So these are some examples of domain-specific AIs that we may have seen or that we're already using ourselves. So Martin and I would like to share with you a couple of practical classroom scenarios, just to give you the taste of what is feasible for you in the classroom already. So look at this one here. You may have seen Quick Draw with Google. It's a wonderful interactive example where you or the student can draw something with the mouse or the stylus on the screen, and then the AI is analyzing this pretty much in real time and starts making suggestions. So this is about the ability of my, or the artistic capability that I have with a mouse on a screen. So I can make a smiley with that. And you see, as I'm drawing, the AI will first say, well, I'm seeing, what am I seeing? Nothing. I'm seeing eyeglasses. I'm seeing sunglasses. Oh, peas. Not sure where the peas in the stethoscope comes from, but when I'm done, it says, well, it's seeing a smiley face. And that's a very simple thing that you can use in the classroom. Apparently, this particular implementation is not just doing image processing, it also observes us as we draw the strokes, the direction in which we draw them, and it takes all that into account when it makes its decision. So several factors that are in play here. Okay. Now, as your students are using this, they will say, well, that's very interesting, but how might this look internally? How does the AI come up with a decision? So let's have a look at this example here, which is a different system. This is my computer brain. And you see here how we have a very simple image, an emoji, on a 7x5 dot matrix. And it knows only 4 emojis. It knows happy, sad, surprised, and serious faces. But we can start manipulating the pixels. And as we manipulate them, the AI will calculate through this network that you see here and come up with suggestions. And we'll say, well, I'm seeing a happy face, a sad face, I'm seeing a surprised face, or an angry face. It gets interesting when we combine these faces. For example, here, where we combine the happy and the sad face. Yeah, I said, well, from what I know, I'm kind of seeing both here. Okay, so this is an artificial neural network implementing image recognition. I'll talk a bit more about that later. A second example for you to play with, and this goes into the domain of Siri, Alexa, and friends, is how a personal assistant might work. So whilst you would talk to a system, in this case, it's a bit simpler. We are typing in some commands. And the idea of this system is that it would be able to switch your lights on or off, or turn the fan on or off based on your commands. So it has been trained with certain sentences, with word combinations like switch lights on, switch lights off, turn the fan on, turn the fan off. And it's doing its learning here based on the data. So remember what we said earlier, it gets data and then it needs to learn. And here we've got the results. So it's too bright, too dark. And when we then enter a command, like it's too warm, well, turn the fan on. And if it is too bright, turn the lights off. Again, it gets interesting when we start combining things that are not pre-trained. Like, for example, it's cold and bright. Well, of course, turn the lights off and the fan off, so it can combine these things very nicely. Okay. Once you get a hang of this, how the AI works, then you can think about different scenarios because they're all a bit similar. So take a look at the next one. This one here is a sentiment analysis. In the particular implementation, it's an anti-bullying AI. The scenario here is that as kids write things on social media, they sometimes write them in a hurry, and they're not quite clear that what they're writing can be offensive. So this particular AI here, which is really just a classroom scenario, not a proactive version, has been trained with 6 examples of nice things and 6 examples of mean things, which you see in the table here on the right. So a nice thing to say could be, I like you, or your hair looks nice, I think you're great, you have a great smile, you're so clever, and I love your outfit. These are nice things to say. I think we all agree with that. Mean things in this scenario is, you smell, I hate you, that's dumb, and now I stop here as I don't want to ruin your day. Okay, but the AI has been trained with these things, and you can see that here. And we can now type in a command like, you smell so nice. And you see how this is a combination between a nice thing to say and a mean thing to say. Because what we taught the AI, the nice thing is your hair looks nice. And the mean thing is you smell. So at no point did we tell the AI what you smell so nice actually means. Is it a nice thing or a mean thing? And you see how it makes it sense. So as we type in you smell, it initially says that's a mean thing. Like, you see it, you smell. And then as we add so nice, it really flips it over. And it's a correct assessment in this case, because you smell so nice is actually a nice thing to say. So again, AI is able to interpolate between given scenarios in a way that is similar to the way we would do it as humans. It mimics our human thinking. So in the previous 2 scenarios, there's an aspect of natural language processing, because in the real world, especially with Alexa and Siri and friends, we would talk to the system. So the information, our voice needs to be processed first, needs to be broken into words that the system can then understand, and then feed it into the AI in order to come up with a decision. So you see here how with AI we are enabling the machine to be much more human compatible. And especially compare this with the early days of computing, where we had to plug wires in order to communicate with the system. So we had to completely adapt to the way the machine did it. And increasingly, the machine is adapting to the way that we like to communicate, and it's getting better and better at that. Also, and we will talk this a little bit later, is that when the AI is not quite certain about something, it can talk and return to us and ask for additional information in order to ascertain what we really want before it takes a decision. So that's an additional step where the AI can seek for further information. So you see how these things start to connect here: AI, natural language processing. Here's another example on our little example show in this presentation. This one here is a typical scenario in science, whether this kids do physics or chemistry, they measure something. In this case, it's a chemical reaction, and the student had to measure the temperature, which you see in the x-axis, and the time for the reaction, which is on the y-axis. And you see the black dots. These are the results from the experiment, and then the student had the task now to find the best fitting curve. Conventionally, the students do this in a spreadsheet application like Excel. They plot the data, and then they go and look for the curve and say, well, I want exponential or polynomial or linear, and then play around with that. In this case here, we're doing no such thing. We're just throwing the data at the AI and say, have fun. Tell me what you think is the best curve. And you see how it increasingly fits the black dots. And then in the end, we can see the red line being drawn. And here it is. Okay, so now all of a sudden we've got these connecting dots. So the AI interpolates. It connects two dots that were previously unconnected. And that allows the AI to do forecasts like, you smell so nice. Okay, it's the same principle here. Although here we're only operating in the two-dimensional space, AIs like to operate in the multi-dimensional space. The mathematicians amongst you would be very happy with that. Okay, but we're not going into that today. So, having given you a few examples as an impression of what might be possible for you in the classroom, and we will come back to lesson ideas later, let's talk about some of the AI misconceptions. Okay, that was me. One of the misconceptions is that AI is always about robotics. And the reality, at least up to today, is that AI is generally not connected to robots. In some cases they are, but if you think about your personal assistant here, I don't see a robot here, it's not connected to a robot. Okay, so these things sit on big server farms, they crunch data, they predict stock prices and so on and so forth. So they're not connected to robots. However, they can be, like any control and decision systems, they can be. If you watch the Terminator movie, of course, that's nice and science fiction, probably going to happen anytime soon. The other misconception is that in order to do AI, we need massive, big data sets. Well, the reality is AI can work also with small data sets. The examples I've shown you previously, really small data sets. The student had 15 data points. That was it. The smileys, we had 4 smileys. Okay, we could get it. We were able to get it going with this small number of data sets, like less than 10 in many cases, and it's definitely suitable for a school environment. Having said that, the larger the data set and the more variation in the data, it improves accuracy. So if you, certainly for the industrial application, we've got massive data sets, but in order to get a feeling for it in the school environment, small data sets that students can collect themselves and create themselves is absolutely feasible. Okay, so having clarified some of the misconceptions, let's talk about the differences of AI to what we would call as quote unquote conventional computing. Okay, so those of you who have developed code, okay, is a programmer writes a computer program and it pretty much precisely instructs the computer what to do to solve a particular problem. Okay, conventional programming. With the AI, the programmer first writes a program, which is the AI, as a general purpose engine, so to say, that allows the computer to learn to solve any problem by itself. Any is a bit hard because there are many possible variations, but a large number of problems, let's say it this way. And then a user of that program, the AI, feeds data into it and says, have a go. Like what I did previously by feeding these 15 data points of the chemistry experiment into the AI. And the AI had no idea that it was actually dealing with chemistry. Could have been anything. It was just data from the perspective of the AI. And all I did there was visualizing the outcomes. Okay, so that's the main difference. We can also look at it in a different way. So in conventional programming, I've got many programs for many problems. And in order to solve all these different variations of the data, they would be full of if then else statements or pre-processing to do something with the data. In AI, we have essentially one program for many problems, and it's full of data examples. Just feed data into the AI and let it come up with something. And it doesn't always work. Okay, sometimes AIs don't converge and they just start oscillating and we don't get anything out of them. Then we have to fiddle with them, with the internal setup a little bit. So let's look at types of AI. And this is a very nice infographics created by Erica Southgate, which we liked and use here. So the AI that we have spoken about so far is what she calls a narrow AI. So it's an AI focused on a single purpose, like, for example, a chess player, face recognition, stock forecast, or something like this, specific for a particular purpose. Okay. The next step would be what she calls a general AI. So this would be an AI that's able to think and act like a human. Okay. As far as we know, this type of AI only exists in science fiction so far. It hasn't been realized yet. The reason for that is when you train an AI, you always train in context specific, and it's very difficult for an AI to understand what context is. So for an AI to switch between chess playing and, let's say, performing surgery are very big things. We haven't figured that out yet, apparently. And I'll explain that in a moment. A super AI would be a super intelligence way above human intelligence that is way better at thinking than humans can. And also, to our knowledge, this kind of super AI does only exist in science fiction. Now, I'm saying as far as we know, because the reality is if anyone ever developed a super AI, that person would be very clever not to tell anyone. Because if you had a super AI, you could make a lot of money by predicting the share market and solving diseases, and you could create companies that would monetize that, and therefore it would be quite foolish of that person from a commercial perspective to tell the rest of the world that they have that. Okay, a little bit like the imitation game with Alan Turing when they had cracked the Enigma code. They had to run essentially under the statistic probability in order to win the war. By the way, great movie that can be watched. It's great. But in the context of the school environment, we talk about narrow AIs for specific purposes. And the rest, at the moment, at least to our knowledge, is science fiction. Good. So we said, well, this is today not only about AI, it's also about machine learning. So we said, what's the difference between the two? And it is actually difficult because when you look into the literature, the both terms are often used interchangeably. But generally speaking, machine learning is an application of AI. On a high level, if you take lots of data and cloud computing capabilities and some clever algorithms, then you get machine learning, roughly. Okay. Same principle, you give lots of examples of data, we demonstrate what we would like it to do so that it can figure out to achieve a goal on its own. In a sense, machine learning is a subset of AI. It's about certain techniques that we currently deploy, like artificial neural networks and so on, in order to make AI happen. But AI is, you can say, it's a little bit like a concept in the same way that informatics is the general concept under which computer science falls. That's maybe an analog we can work with. Okay, in any case, the machine that learns and adapts its strategy to achieve a certain goal. Okay, so in a school environment, within machine learning are artificial neural networks. You've probably heard about them. We lovingly abbreviate them as ANNs. When they are certain levels deep, we also talk about deep learning here. It's about the depth of the layers, and I'll show you some later. They are actually inspired by the workings of the biological brain's neural network. So that's research that was started about 40, 50 years ago when scientists started to understand how the human brain works. And as part of their studies, they developed computer models and then found, oh, it works. And that became a branch of its own. And these are now the artificial neural networks. They can, like us, ANNs can learn to identify patterns, and they're using a feedback loop. And the same thing that is happening in the school And the way that we learn as humans is we do something, we make a mistake, and we learn from our mistakes. We burn our hands. We say, well, that wasn't the right place to put our hand. In the school environment, you're teaching your kids to learn A, B, and C. You show the letter to them, you say it, you let the kids repeat it. So that's the same thing that an artificial neural network learns, just faster. And personally, I very much like artificial neural networks because of its link to biology, and I've seen it's a really good opportunity to discuss human learning with your students. And you can show them a neural network and you can run experiments on it, and with that the students get an understanding how they learn. So it's an opportunity for you to think with them about mental growth models and how they can become more efficient learners. I've had these discussions with kids, and it's quite amazing when they see an artificial neural network learn and how it also forgets things. And that's a way to show your students how they can, maybe how they should learn in a certain way so that they don't forget and they retain knowledge better. We can show now why revision is important, for example, in the model of the artificial neural network. So I think ANNs are a great tool for a classroom environment, not just from the technological perspective, but also from the biological perspective in helping students to become better learners. Okay, so the question is, we've seen this earlier, what makes an AI or machine learning so unique? So in a nutshell, the world around us, the natural world, is full of fuzzy data. Okay, so you hear me speaking with a German accent here, and I apologize, despite 20 years in Australia, I still have a German accent. When you work in science and engineering, it's actually not a bad thing to have. Despite my best efforts, I couldn't get rid of it, but you can understand me. Okay, so there's certain inflections that I'm using, and despite them, you can still understand me because you've got an artificial neural network which is able to deal with this fuzzy data. I deviate from Oxford English. Actually, everyone from us here in this virtual room probably deviates or doesn't speak Oxford English. Nonetheless, we can understand each other. Okay, and artificial neural networks have the same capability. So with these many variations, conventional programs would struggle to come up with all the possible combinations, but an AI can. So take this, for example, like in a 7x5 matrix, that's 35-bit, there are over 34 billion possible combinations of black and white pixels to represent an image, okay? So 34 billion. Try to write that program that discovers what the letter A is exactly with just all the possible permutation, because you can have this kind of A, or the one that I'm showing, lowercase, it can be rotated and everything. We can train an AI to discover that itself. So have a look at this one. This one is a little AI, and it has been trained on the letters A to J, just capital letters, nothing too fancy. And then we show it this pattern here on the left. See this one? What is that? We never gave it that particular pattern. But it looks at what it knows in its little universe between A to J, and it says, well, this most likely, I'm confident. Confident is an important word here. I'm confident that this pattern most likely resembles an F. And from our human perspective, we would probably agree with that. Well, there's a little dot too much down there at the bottom left, but then the horizontal bar looks like partially removed, so it could be an F. It could also be a G where a couple of pixels have been removed. But in general, we agree with the prediction of the system. And you see the F here is gray, and that shows that the confidence is not that high because there's a lot of information missing. And if you look very carefully, I'm not sure if you can see this on your screen, but you can also barely see the C down here and the J. So there's an element of C-ishness, if that is actually English, I'm not sure, in this thing here, because the C is partially included in this character here. So it has a very low confidence that it's a C, but it could be a C. But the highest confidence is with an F. And you know, we humans, we do the same thing. When we're not quite sure, we say, well, it might be that, or could be this, I'm not sure, but probably. so we express this through our natural language. We are the same. When our brain produces a confidence level that is low, then we express this through our language and sometimes through our behavior. And sometimes we make mistakes, and that's why AIs will make the same mistakes that we do. They just make them faster. Okay, so what are the main types of machine learning for a school environment? There are many types. Some of them are mathematically very complex, but we think that for a school environment, two major types would be of interest for you. There's the supervised learning, the artificial neural networks or deep learning that we already mentioned, where you've got input data and a description of what this data means. So you have a pixel or a grid of pixels and an annotation to the data that says it's an A or it's a B or a C. And then the system can start going and do its looping and refinement and eventually learn this. This is the closest link to biological learning that we have at the moment. The other column here on the right is the unsupervised learning, where we just have input data, and then we have statistical models for grouping or clustering of data points. So all comes down to that. So you've got biological learning or statistics. There's a brilliant article on the Wikipedia website, the machine learning article, that we highly recommend you reading if you've got the time, that does the further down classification if you're interested, but maybe on the high level, supervised and unsupervised learning for the school environment. Okay, there is a brilliant video by the computer science crash course. This one is number 34. If you don't know the series of computer science crash courses, they're all worth watching. This particular video here is on artificial intelligence and machine learning, and she does a brilliant introduction and overview of the whole topic. So if you only have got time to watch one video out of this whole webinar, apart from the webinar itself, we think that's the video to watch. Okay. And what AI does, and you see this also in the video here, is classification. So this is a bit of an unplugged activity that you can do in the classroom. See, we've got classifications for what's a koala, kangaroo, wombat, echidna, in relation to its covering, its limbs, its paws, its ears, its nose, and its tail. And when we then have an unknown animal, like the one on the right here, where we know some things, but not all of them, like we're not sure what it is. We think it has fur, we're not sure about the limbs because we can't quite see them. And we think it has paws, yes, large, fluffy, large, black, and it doesn't have a tail. And then we can start mapping them against what we know. Oops, almost back. And then the AI will say, well, there's a similarity score or a confidence score. In this case, the highest is with koala, but to a certain extent, it could also be a wombat. So it's not so much a yes and no decision, but it's almost like a probability decision. Probably koala, the highest probability, wombat, then an echidna and kangaroo. And that's how the AI does that. And in the video here, they explain this very nicely, probably better than I just did. Okay. Have a look at that. So let's talk about some of the ethical and critical aspects of artificial intelligence. So the use of AI raises some concerns because now we have computers entering the domain of humans where we are legally responsible. Okay. So the big question, of course, is that what will happen when an AI surpasses human intelligence? That's a good question. We don't have superhuman intelligence yet, as we saw it. So that is not the question of immediate concern, although the philosophers are asking themselves that question, what will be our future role if there's a super intelligence? More prevalent is like who's responsible when things go wrong. Okay, and I'll give you an example. So as you know, the machine learning comes with a confidence value, as we've seen earlier with our little letter which resembled an F. So if an image shows something which the AI thinks, well, 40% pedestrian, what are the implications of that? So let's talk about that. So the question is, should a car stop if it detects a pedestrian on the road with a 40% confidence? And that leads us to the question, what is the right threshold for the program, which then uses the AI results to make a decision? So what is the right threshold? If the threshold, let's say, is too low, then the car might brake unnecessarily, maybe all the time. It's interrupting traffic flow, maybe causing accidents and collisions behind the car. And as a consequence, people in those cars might get injured or killed. Okay, certainly not something we want. But if the threshold is too high, then the car doesn't brake when it detects a pedestrian with a 40% confidence and could run over the pedestrian. Well, it's a potential loss of life in both cases. Now, somebody needs to decide what the confidence value is. Maybe there's actually a separate AI which decides to set the right confidence value, but then when the machine makes a mistake and the car kills a pedestrian, who's responsible? Is it the AI? Is it the manufacturer of the AI? Or is it the operator of the AI? In this case, maybe me driving the car as the licensed driver. All good questions that haven't really been resolved yet, and we've seen the first couple of accidents with AI self-driving cars. And as more of those cars will come on the roads, naturally those accidents will occur more, and big question for the insurance companies and so on. Martin?
Yeah, there's also, I saw a similar sort of activity where there was a pedestrian crossing the road. She's got a pram and a baby, but then there's also an elderly person. So does the car avoid the elderly person or avoid the person crossing the road with the baby? You know, that sort of dilemma. Is there a life that's less worthy? So that's sort of another dilemma on top.
And it's a very good example. And what do we take into account? Do we take in the future life potential of the baby, or the achievements of the elderly person? Maybe that's a Nobel Prize laureate. Okay, so there's a lot of knowledge that would get lost. Who makes that decision, right? Yeah, we don't have an answer to that. It's a question for the philosophers to get into. So, question for you is, think about that. Would you accept being operated on by an AI surgeon, for example? Well, we already have got robots in the surgery, in the operating theaters. Maybe that being controlled by an AI would be good. Generally, these robots seem to be doing well, as far as I understand that the complications with hip replacements are far lower with robotic doctors. Currently, they're remote controlled. Sometimes they run a specific program, but what if an AI did that? I don't know. Good questions. Another one, would you accept your legal case to be ruled by an AI judge? After all, the AI would know about all the case law. Okay, it should be unbiased. But is it? Like, what if the AI is biased? Okay, because it could be biased training data. It goes into the training. As you've seen, the AI needs to be trained, and its universe consists of the data that we provide to it. Okay, what if our collection method of the data is also biased? So if I run around and just take photos of yellow plants, then my AI would have no idea of red plants or red flowers. There are videos that we've collected, for example, about the racial issues here in face recognition. There's an American student who made a case that these algorithms do not detect people of certain ethnicities. And the reality is that every subset of anything is biased. And we just don't have the possibility to collect every piece of information in the world. So we have to make a decision of what we include in our data set and what we don't. And that automatically leads to a bias. Maybe it is possible to have an unbiased data set when it comes to law, but as we also know, and that's why we've got courts, is that law is always open to interpretation. Now, I'm not a lawyer, I'm not giving any legal advice here, but if we didn't have an interpretation in the law, then it would be crystal clear and we wouldn't need judges and juries. So it's a good question what we do here. And I understand that there are people already thinking and studying and writing theses about AI judges. Okay, good. So here's another question, and that comes back to what Martin said. What if the AI reaches conclusions that go against our human ethics? Grandmother, baby. How do we decide? Okay. How do we give our AI ethics? Because by putting ethics into it, we are adding actually a bias, and we don't want biases on the other side. So all good questions, which we don't have the answers for today. Would probably win us a Nobel Prize. So that we leave that for another day. So let's talk about AI and the Australian curriculum then. Here. Here's the thing. In technologies, AI is actually not mentioned explicitly in any of the content descriptors. Okay, full disclaimer, it's not there. If you're looking for it, you won't find it. However, AI is really a good application of computational thinking, abstraction, and decomposition. You see, for example, how a big problem gets broken down into little activities that each of these neurons, or they're called perceptrons technically, is executing, and then is being recombined, and we've got a result. So you can look at AI and you find many of the key concepts in the Australian curriculum, as we will show shortly. It also is a very valid and interesting context of applications, and your students would be able to identify with those. So because they're watching Netflix, they are getting recommendations, they are interacting with their voice assistants and so on. So when you use AI examples in the classroom, the students will probably say, yes, of course, I've got something to contribute here, I've got an experience. So you've got a hook here. So that's the personal experience. There are many real world applications for investigation. We've seen some of them, like driverless cars, face recognition. We can talk about the of that and the social impacts of technology, some of the moral implications. What if we have super intelligence? What will be the role of humans in that world? And we think it's really scalable, both for primary and secondary students, concepts of the Australian curriculum. So what we have done is we have mapped it against the key concepts of the Australian curriculum. So that is the one step before the content descriptors. And go have a look at the Australian curriculum, Australian Computing Academy website, because there you find a really nice unpacking of the Australian curriculum digital technologies and a description of the key concepts, which we have copied here on the left-hand side. And then we have mapped AI against that. We won't have time to go through all of them, but just have a look here, because every of the key concepts can be addressed in one way or another with aspects of artificial intelligence. Especially lends itself to these points here, which are always very difficult, like impact and interactions. Okay, in addition to the technical side of specification, algorithms, and implementation. Okay. There's further detailed work against the mapping against the content descriptors, which you will find on the Digital Technologies Hub website. And this is just a screenshot of 2 of the content descriptors for the year 5 and 6 students. Again, we don't have enough time in this webinar today to go through them, but when you've got a chance, go to this link. So Australian Computing Academy for the breakdown of the content of the key concepts, and then the Digital Technologies Hub for the content descriptors mapping. Right. I think we've already mentioned this, the other subject areas.
I might just mention
biology.
Yeah, I just might mention here, give you a bit of a break, Karsten. You know, this general capabilities, their ethical understanding, this is a really good area that you can start to talk about those aspects that Karsten was talking about. So, you know, exploring the values of rights and responsibilities, looking at ethical concepts and issues, so that self-driving cars and those issues. We don't have to have programming type activities. You know, some of the activities can be just unplugged activities where students are working through some of the dilemmas and some of the moral and ethical issues that we're talking about. So I think that's something really good to do. Now, I might just jump into the next slide about some of the resources. And the first resource is on the DT Hub, and that just follows on with this Year 10. It's a really fantastic lesson, or it's a sort of a explanation of a lesson that was done with this Year 10 class. And I think if you use that as a bit of a guide to see what you can do in terms of ethical understandings and what can you do with the students. This one's at Year 10, but you can sort of see what the focus there was on what's a preferred future look like with AI. And the students did their own investigations and case studies on what they thought would be good uses of AI in a preferred future. There's student lessons, sort of student work samples there, videos they're really entertaining. They're a magic job in terms of what the students have produced. So I think as a starting point, if you've got a sort of a secondary class and you just want to see how you might approach that, I'd definitely have a look at that lesson and the feedback from the teacher and how they put that together. This next one is what Karsten was talking about on the DT Hub. We've put together a topics page, and this is a really good starting point just to say, you know, it's really a lot of the things we've covered in this webinar. What is artificial intelligence, how it's different from normal computing, some of the aspects to the curriculum. You'll find it all here. Some of those little applications that Karsten showed you, the Google Draw and so on, there's links to these on this part of the site. So in the handout, we've given you the links to that resource there.
Mm-hmm. On the Hub, you will also find a growing collection of videos. The PBS Kids we already mentioned, and this video here is also a very nice and good summary of artificial intelligence and a number of good examples that you may want to watch.
Our friends at CSDR have done a magnificent job in putting together a MOOC, and you might have attended one of the MOOCs, I would assume, for either primary or secondary in terms of digital technologies. Again, the following work on this area, the core concepts that they're covering, really a great introduction. And then for each one of primary or secondary, they've got some classroom AI activities. So I recommend, if you want to learn more about AI in a self-paced way, Rebecca and Kat do a fantastic job in putting that together.
Mm-hmm. This one here is an online course for students. Full disclaimer, that's mine. I built this originally for my own children, okay? Then put it online. So here you can look into an artificial neural network, see it at work. As you've seen examples earlier in the presentation. We cover things like image recognition, face recognition. There's the example of an AI librarian from the school environment, the home automation, the anti-bullying example. And there are also examples in there what happens when we forget something and why we shouldn't watch YouTube directly after having learned mathematics and so on and so forth. So as I told you, developed for the students in mind. So have a look at that.
Yep, and this unplugged lesson, it's this example, Joshua Ho, we did a website, a webinar last year, and Joshua was talking about a facial recognition unplugged activity he did with, he used the Disney princesses, but you know, you could use, that's why we used the wombat and the koala as an example, those Australian animals. It's a similar idea, your classification, and looking for what's closest to a set of features or attributes. Again, if you wanted to have a look at that as a lesson, and you could try your own things in terms of, doesn't have to be Australian animals, could be fruit or whatever type of thing you want to classify. But I'd have a look at that lesson.
There are also a number of articles on the DT Hub website. This one here is from the Sydney Morning Herald. This one was about AI for social good, an example from India, a flood-prone region, and I think it was Google in this case. They're using AI in order to predict flood levels and in order to issue warnings in time so that people can evacuate. So it's about an application for AI in India. Then there was a recently released report by the Australian government, Department of Education, authored by Erica Southgate and fellow authors. The report is on artificial intelligence and emerging technologies in schools. I understand it was released last week, if I'm correct. It was commissioned by the Australian government, Department of Education. It examines the literature and it provides advice to teachers on AI and emerging technologies in that context, such as virtual and augmented mixed reality in school education. I haven't quite finished reading the report. I started reading it. I find it very comprehensive, and if you want to dive deeper into the topic of AI, specifically what it means in a school classroom environment, then I highly recommend reading this report.
There's also, it'll be published on the DT Hub, and there's also some short reads. So if you don't have all the time and you just want a quick synopsis, that short reads also will be available. So let's go into some lesson ideas now. This is really just taking some of the ideas that Karsten's taken us through, and let's have a look at something you could do at F2. You know, again, you could just do this as if you feel comfortable, but it's emotions and something you would do at F2, and so it's something that you would already be covering. But how would we sort of look at that if we looked at through an AI lens? What might we do? Well, we could sort of have those emotions, the 7 I've just picked out here. You could, you know, you could ask the students, how would a computer recognise those emotions? Imagine if you took a photo of each one of your students and they would do a particular emotion, which, you know, the AI would have to try and guess. Then, you know, if the student was the AI computer, for example, and trying to work out from the image that they see, you know, what is the emotion that they're seeing, and then how are they working it out. It'll be a great little unplugged activity. A variation of that would be to have a video of someone and then using the speech and facial movements. That's obviously, again, another variation on top of that, but certainly would be quite a fun little activity to do with your students. Next one is, we're just using that animal classification one we had earlier. You could open it up. It doesn't have to be mammals. It could be fish, birds, reptiles, amphibians, so on. But the focus there would be to have creating a features table, and from that, you know, you're able to classify some images. So if you've got some really interesting images, how does the AI, you know, what score do they give in terms of your features table? You know, you could do a plugged activity then, have a scratch game and have some way that the user is guessing an animal based on the features. It's not actually using AI, but what we're trying to do there is bring together the attributes that we're using for classification. In year 5-6, you might have a play around with speech recognition. So, you know, if you've got one of the personal assistants, it could be a Google Home or a Siri or Alexa or something similar, you know, have a bit of a play around with that, explore that, how it works, using some simple questions. Imagine if you had a short quiz produced and you had 3 contestants, 2 students and 1 was the AI assistant. You know, it might be interesting to see how that pans out in terms of answering the questions. Then you could try
if I can just add to this, Martin, the Australian Computing Academy has this brilliant chatbot course, both in Python and in Blockly, where students can program their own chatbot in order to get a sense of, it's not AI, but it gives them a sense of the work required in hard coding these commands and how much work it is required there. So that's also a good resource to use.
I agree with that one, and also there you could just sort of talk about the limitations of the coding. So, you know, that's why AI is so good, because basically you're not hard coding it, it's learning as it goes. So thanks for that. And here's another example for years 7 and 8, you might do a focus on speech recognition system, and then it's bringing up what Karsten was talking about before about bias. Now, if your data set doesn't include a diverse range of speakers, imagine if you've got some sort of entry into an area, and that's based on some speech recognition. You know, if you've got having a large data set, there might be some issues in terms of understanding various speakers and so on. So it'd be a great little activity to sort of get into. And there's a website called Machine Learning for Kids, and it allows you to play around with different sorts of data sets, and it's a really good intro into AI. I don't know if you want to say any more about that one, Karsten.
It allows you to define your own data sets, and it then trains an AI which is on one of the big server farms, and you can connect to that, I think, through Scratch, if I'm correct. You can write Scratch games that use the AI then, yeah.
Yeah. And for year 7 and 10, we're under development, we're looking at using chatbots and book analysis to explore natural language processing, and Karsten did talk about that as well. And one of the things we're looking at there is the sentiment analysis. So we're using Python programming, and there'll be some video tutorials, a lesson, a slide deck, and some sample code that will support this whole process. And this would be, there'll be a sort of more general lesson for the sort of year 7 and 8, so they can get an idea about it. But the year 9 and 10 will be quite focused in terms of using Python programming in a step-by-step way to sort of take you through how, you know, it might do a simple AI application. When I say simple, it's quite difficult, but you know, it'll be worked through that. So we're looking forward to getting that lesson up and running, and it's more like a module of lessons put together. But yeah, that should be really interesting.
So for all of that and more, visit and revisit the growing collection on the Digital Technologies Hub. It is, Martin, it's work in progress, so new resources are being added on a regular basis. So if you go there, if you don't find what you're looking for, it's worthwhile coming back in a week or two, and it may have been added in the meantime.
We're looking to put on the homepage an artificial intelligence section, but that's a work in progress. But if you just search by keyword artificial intelligence, whatever resources we have, you'll discover that way. And then filter for the year levels.
Now that brings us to the beginning of the end. So we close with a summary. So we hope you enjoyed the session and it added value. In summary, what we want to leave you with is AI is about making computers smarter by allowing them to learn or to mimic human intelligence. Machine learning is the application of AI using big data and powerful computing. Some of the approaches in machine learning are inspired by biology, and you've seen this with the artificial neural networks, which we find quite useful in the classroom environment because of this link to biology. And AI, although not explicitly mentioned, AI does connect with the Australian curriculum, digital technologies, and it can be helpful for you as a classroom teachers to help reflect on human learning and to help your students become more efficient learners. And that's it from our side, is it?
Yeah, that's it. Good. Thank you very much, Karsten. You've done an amazing job in pulling that all together. You know, our idea here is really an intro into artificial intelligence, and you know, take the bits and pieces that make sense to you, and if you want to implement some of the ideas we've given you, we're going to put some more lessons together. As I mentioned, the MOOC on the AI, I really recommend having a look at that because they talk through some of the core concepts and really give a great understanding of what AI is all about. So until our next webinar, we'll see you then. And thank you very much, Karsten. We'll speak soon. Thank you very much. Bye.
Thank you, Martin. Thank you, everyone. Bye.
See you. Bye.